This is the video 2 of MEKG video series. In this video, industrial chemistry topics are discussed. Topic 1: Environment Management System.
The company management meets to take stock of the situation. They decide to implement an environmental management system, EMS, in compliance with ISO 14001 standards. The consultant gives an introductory presentation, highlighting the various requirements, important elements, and the advantages of an effective environmental management system.
Topic 2: Benefits of EMS.
An environmental-friendly car manufacturing company is in the lookout for environmental-friendly ships to transport their cars. The car manufacturer's representative audits the company's EMS and finds it in line with his requirements. The car manufacturing company charters the vessels on a long-term basis. One of the company's vessels arrives at a bunkering port to receive bunkers. During the operation, one of the fuel oil tank valve indicator malfunctions and shows in the open position. The third engineer, assuming that the valve is opened, lines up the tank for receiving bunker. Due to high pressure, the bunker hose bursts and oil flows overboard and pollutes the port. The court directs the company to pay for the cleanup costs, but does not impose any fine. The court feels that the company has an effective environmental management system and has carried out all possible preventative measures to prevent the accident. Following a pollution incident, a company implements an environmental management system. However, with the system in place, another incident occurs. It can be seen that the company is now looked at favorably by the authorities as it has an effective environment management system in place.
Topic 3: Greenhouse Effect.
In cold places, flowers, vegetables, and fruits are grown in glass-covered areas called greenhouse. When the sunlight falls on a greenhouse, the light radiations easily passes through the glass roof and warms up the plant and soil inside. The warm soil and plants emit infrared radiations. Since glass is opaque to infrared radiations, it partly reflects and partly absorbs these radiations. Similarly, about 75% of the solar energy reaching the earth is absorbed by the earth's surface, which increases its temperature. The rest of the heat radiates back to the atmosphere. However, since the beginning of the 20th century, the proportion of the individual gases in the atmosphere has been disturbed. Millions of tons of coal, oil, and natural gas are burnt every day, producing huge amounts of carbon dioxide. At the same time, the vast areas of forest has been cut down. That reduces the number of plants that absorb carbon dioxide during photosynthesis. As a result, the concentration of carbon dioxide in the atmosphere increases. This gas acts in a similar manner as a glass roof in the greenhouse. Thus, carbon dioxide molecules also traps heat and increase the global temperature. This phenomenon is referred to as global warming or greenhouse effect. Carbon dioxide is a major contributor to global warming. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, and chlorofluorocarbon.
Topic 4: Lubricating Oil System.
Components. Main lubricating system consists of storage tanks for lubricating oil. They are fitted at higher levels in the engine room to bunker the oil easily. The arrangement provides a positive head to the system. Main engine lubricating oil sump receives oil from the storage tank. Main lubricating oil supply pump takes suction from the sump and supplies it to the main bearings, crosshead guides, guide shoes, and other components of the engine. Repeated use of the oil makes it hot and dirty. It is cleaned by a set of purifiers. The temperature of the oil is brought down to the working levels by coolers. They can either be shell and tube type or plate type. A three-way valve regulates the temperature of the oil entering the engine. It is placed just after the cooler and allows part of the oil to bypass without being cooled. Auto backwash filter is one of the critical elements in the system. This ensures that clean oil enters the bearings and other working parts, which have fine running clearances. Debris in the oil chokes the passage of oil flow. Hence, the oil that is drained from the stuffing box of the engine cannot be reused directly. A CJC filter is used to filter the oil. Further purification is carried out by the centrifuges to make the oil reusable. Having familiarized yourself with the components, move on to see how they can be connected together to work as a system. The hand pump transfers cylinder oil in the storage tank to the service tank. From here, the oil flows to the engine-driven lubricators by gravity. The main engine lubricating oil pump takes suction from the lubricating oil sump tank through a duplex strainer. It supplies the oil to the main engine through a cooler and auto backwash filter. From the storage tank, lubricating oil is transferred to the lubricating oil sump tank by gravity, as and when required. The purifier feed pump takes suction from the lubricating oil sump tank and supplies it to the purifier through a heater. The purified oil is delivered back to the sump. The used oil from the stuffing box is drained to the dirty oil tank. The purifier purifies the dirty oil and transfers it to the clean oil tank. The CJC filter further purifies this oil and transfers it to the lubricating oil sump tank. In any dynamic system, the process is reflected by its parameter. Any parameter deviating in value from its normal levels will signify a change in the system process. For example, if the temperature of oil at engine inlet is higher than normal, it indicates a wrong setting on the viscosity regulator. If the pressure of the oil at engine inlet is lower than normal, it indicates a clogged filter. Safety devices warn the operator of any deviation. The highlighted devices of the system act as frontline safety provisions, which trigger the actual safety alarms, shutdowns, or isolations. Temperature transmitters, pressure transmitters, level transmitters also provide first-level protection against system breakdowns.
Topic 5: Bunkering System.
Bunkering system. A typical bunkering system on any ship consists of manifold connection on deck, manifold valves, sampling units for taking samples, temperature and pressure gauges, pipelines, line valves, storage tanks, settling and service tanks, and transfer pumps. Before bunkering, only those valves must be opened for the tanks which are bunkered. All other valves must be shut. For example, if we are bunkering in one port and one starboard, the following valves must be open: manifold valve, master valve, one port, and other starboard valve. All other valves must be shut. See the simple animation to view the flow of fuel oil in both tanks. Remember, Check soundings of other tanks and confirm there is no rise in levels. This is to make sure that there are no leaking valves or valves that are kept accidentally open.
Topic 6. Fuel oil system.
A typical fuel oil system consists of bunker tanks at the bottom. They can be double-bottom tanks or wing tanks into which the oil is bunkered. The transfer pumps transfer the fuel oil from the bunker tanks to settling tank, where water is separated from the oil. After primary separation, the oil is sent to purifiers where purification takes place. It is then passed to service tanks. Individual settling and service tanks are provided for diesel and heavy oil. Supply and booster pumps are positive displacement pumps. They are duplicated in the system. The supply pumps transfer the oil from the service tanks to mixing column. The fuel from the mixing column close to the suction side of booster pump. A flow meter measures the oil consumption. The booster pumps supply this purified oil to heaters, viscosity regulator, full flow filters, and to the fuel main. The full flow filter has verified mesh elements. A bypass filter is provided to clean the full flow filter during operation. The unused oil is returned either to the service tanks or to the mixing column.
Topic 7. Properties of lubricants.
Viscosity. Watch the animations to understand some of the properties of lubricating oil. Viscosity is the internal resistance of a liquid to flow. Viscosity varies inversely with temperature. Greater the temperature, lesser the viscosity. Lesser the temperature, greater the viscosity. The viscosity index, VI, of oil is a number that indicates the effect of the temperature changes on the viscosity of the oil. A low VI signifies a relatively large change of viscosity with changes of temperature. In other words, the oil becomes extremely thin at high temperatures and extremely thick at low temperatures. On the other hand, a high VI signifies relatively little change in viscosity over a wide temperature range. Flashpoint. Flashpoint of a liquid fuel is the minimum temperature at which sufficient vapors are produced and, if ignited externally, gives off a spark. When considering fuels, the flashpoint is determined to indicate the presence of the fire risk. This is particularly important when these types of fuels are used. Liquids with flashpoints of more than 65 degrees Celsius are called non-volatile liquids. And the ones with flashpoints less than 65 degrees Celsius are called volatile liquids. On board, only non-volatile liquids are used. Pour point. Pour point is the temperature below which a liquid ceases to flow. If the liquid ceases to flow, the oil pumps get overloaded and eventually get damaged. Total base number. Total base number, TBN, is the indication of the oil's ability to neutralize the effect of high sulfur fuels. The higher a lube oil's TBN, the more effective it is in suspending wear-causing contaminants and reduce the corrosive effects of acids for an extended period of time.
Take a drop of lube oil from the sample and put it on a filter paper. Wait till the filter paper absorbs the oil. If the stain on the filter paper is light and clear, it indicates that the oil is fresh and can be used. If the stain is uniformly dark, it indicates the oil is in use for some time and can be used. If the stain is very dark, it indicates the oil should be renewed at the earliest opportunity. If the oil is contaminated with diesel or water, the stain will not be uniform. The center will be dark and the periphery will be light. In the viscosity test, the flow of the sample is compared with the flow of fresh oil. If the difference in the levels between the two tubes is negligible, then the lube oil is good. You can use it for some more time. If the level in the sample reads either too high or too low, then it indicates contamination. Change the lube oil immediately. A water test kit is used to measure the water content in lubricants. Take a small quantity of the lubricant to be tested, along with a dry solvent and calcium hydride in a vessel. Calcium hydride reacts with the water, producing hydrogen gas. The pressure displayed on the gauge is proportional to the percentage or ppm of the water present in the sample. The gauge can display water content from 10 to 120,000 ppm over 5 ranges. In hydrodynamic lubrication system, an oil film separates two metal surfaces. In the hydrodynamic lubrication, like in a crankshaft journal, the volatile surface motion between the journals form a fluid wedge over their respective bearing surfaces. Since this pressure generates internally, that is, within the bearing by forceful action, this type of lubrication is called as hydrodynamic lubrication. Boundary lubrication prevents metal-to-metal contact from taking place while starting the engine by providing an inherent thin oil film between the metal surfaces. When a complete fluid film does not develop to the required or designed thickness level between potentially rubbing surfaces, rubbing between the bearing metal surfaces will result, leading to bearing failure. The boundary lubrication conditions exist in all ships during startup and shutdown of equipment, engines, and so on. It also takes place in a piston at TDC or BDC when the relative motion between piston and liner is 0.
Topic 8: Electrochemical corrosion.
When a galvanic cell is formed, the electrons flow from anode to cathode, causing an excess of electrons at the cathode. These enter the electrolyte solution at the surface of cathode. The electrons react with dissolved oxygen and water to form hydroxyl ions. The iron ions from the anode combine with the hydroxyl ions to form iron hydroxides and corrode the anodic area.
Topic 9: Sacrificial anode system.
Sacrificial anode system involves the introduction of a less noble metal that is more electronegative than the existing anodic and cathodic areas. This additional metal becomes the anode and will corrode while providing current to the metal it is protecting. Thus, it overcomes the local anodic areas and makes them cathodic. Sacrificial anode changes the potential of the system and provides protection to steel exposed by wear or damage of the protective coating.
Topic 10: Impressed current cathodic protection.
In operation, the ship's hull potential varies with the ship's hull condition, speed, water salinity, and temperature. The referenced electrode measures the ship's hull potential and transmits the proportional signal to the controller. The controller injects the required current through the fixed anodes to maintain the hull potential so that hull remains cathodic. The anodes are made of lead silver or titanium. They are consumed at a very slow rate and have an approximate life of 10 years.